Okay, here we go. Similarity occurs when we have figures that have the same shape but a different size. You could think like on a copy machine, if you're gonna, push it. I want a copy of this at 70% of the original. It's gonna be the same. Everything's gonna look the same, just smaller. And then I want to make it 125% of the original. Everything's gonna be the same, just bigger. And that's why terms like enlarge or reduce go along with similarity. Same shape, different size. That's the key here. Same shape, different size. And then what happens when you either enlarge or reduce something is that your new version is proportional to the old version. And that's an important word because in order to find side lengths of different figures, we're going to use proportions. We looked at proportions way back at the very beginning of the semester in section 5.1, and then we saw them again in section 7.1 when we were working on pie charts. So it's been a little while, but my guess is that it'll come right back to you. Here we have similar triangles. We can look at those two triangles there. On the left, we have triangle ABC, and on the right, we have triangle DEF. And, just sort of at a quick glance, you can see that they have the same shape, but they're different sizes. And you'd be told in a problem that you have similar triangles if that needs to be told to you. So I have similar triangles here, and what that means is same shape, different size. The angles are the same in the two triangles, it's just that the side lengths are different. What we're going to do is we're going to use a proportion along with, and this is an important word for us, corresponding parts to find missing side lengths. What corresponding parts mean is if you look here at side AB in the triangle on the left, that would correspond to side DE in the triangle on the right. And then side BC would correspond to side EF. And then side AC would correspond to side DF. It's the corresponding sides that are going to help us create relationships between these triangles. They're going to let us find missing side lengths. Usually, it's easy to identify our corresponding parts. Sometimes it can be a little bit challenging. You might have to take a step back and think for a minute, and you'll see those as we go through problems today. So here, I'm given that these are similar triangles. Triangle ABC on the left has side lengths 5, 7, and 10. And I have triangle DEF over on the right. The only one of those I know is that EF has a length of 11. And my job here, my instructions are to find the length of DE to the nearest 10th. So what I'm looking for is DE. So it's going to be really important for me to identify the corresponding part over here in the other triangle. So I've got that relationship set up. DE is what I'm looking for. That's the thing I don't know, so I can call that X. You could call it DE if you want to. Just use DE as your variable there, but I'll go ahead and use X. And now where we start this process is we look for a relationship between these two triangles that we already know. And what I know is BC down here has a length of 7, EF over here has a length of 11. So those two sides that I know, there are corresponding parts. I know how long the one in the small triangle is. I know how long the one in the large triangle is. That's going to give me my relationship between these two triangles. 7 in the small triangle goes with 11 in the big triangle. And I've created this ratio here. And I'm going to use the same ratio when I go to figure out how long is side X. All right, so let's see. 7 in the small triangle, 11 in the big triangle, and I have 5 in the small triangle, X in the big triangle, and I set up this proportion where 7 in the small triangle corresponds with 11 in the big triangle, 5 in the small triangle corresponds with X in the big triangle. Once I've set up my proportion, I can solve it, and I'll know how long side DE is. Solving a proportion, just as a reminder, we cross multiply. 5 times 11 is 55. And this direction, 7 times x is just 7x. In order to get that x by itself, we've got to make multiplication go away. So we'll divide by 7 on the right, divide by 7 on the left. Those cancel, leaving just the x. And 55 divided by 7 is 7.8571. That keeps going, and I'm supposed to round to the nearest tenth. So we'll find the tenths place, one space past the decimal, that's a 5, so we're going to round up to 7.9. So how long is the length? What's the length of side DE? 7.9. So this side right here would have a length of 7.9. One thing I do want to mention is I don't want you to feel like, uh-oh, what if I set this up incorrectly? Well, if you were to have set this up, and I'll do it relatively quickly, but if you were to say, well, I've got 11 in the big triangle and 7 in the little one, so if I set it up as 11 over 7, that's okay. Just make sure you've put the big triangle on top and the small triangle on the bottom. Make sure you're consistent about that. If you do it that way with 11 over 7, then you want to make sure you do x over 5. Big triangle on top, small triangle on the bottom. If you solve this, you'll get 7x equals 55, which is the exact same thing we had down here. So that absolutely works. You can't put them wherever you want. You can't mix and match. Just make sure you're consistent and there's logic to how you set it up. Let me know if you have any questions on this before I have you try one. Okay. Here we have similar triangles, ABC and DEF. I want you to find the length of DF to the nearest hundredth. I'll set up a poll for this one. Last time we rounded to the nearest tenth. This time I rounded to the nearest hundredth. A little bit of that is just a review of place value that you want to make sure you're, the tenths is the one right next to the decimal. The hundredths is, 2 places past the decimal. We haven't done a lot of rounding lately, so just a reminder of place value. And I'll give you time to try it. This is a straightforward, similar triangles type of question. If we know they're similar and we can create a relationship between the 2 triangles, then we can find a missing side length. We can go another, 20 seconds on this one and then talk through it together. All right, let's see how we did here. Unanimous? That's great. That's kind of what I expected. Very good. Let me know if you have questions as we talk through it, though. So basically what we're doing here is we have a situation that involves similar triangles. So what we're going to do is kind of know going in, all right, I'm going to set up a proportion here. That's how I'm going to find that missing side length. The side length I'm looking for is DF over here. I'll call that X. The corresponding part is AC. That's going to be important to me. Then I look for a relationship between the triangles that already exist. I have this 7 and this 11. we did the small triangle on the bottom last time, or no, on the top last time. Let's do the big triangle on top this time. So I'm going to have 11 over 7 is equal to, make sure I follow that logic through, x over 10. Now I have a proportion, and all I need to do is solve it to know how long df is. We'll cross multiply. X times 7 is 7x. 11 times 10 is 110. In order to get that multiplication to go away, we'll divide. Those 7s will cancel, leaving me x. And on the right-hand side, I have 110 divided by 7 is 15.7142. This time, I was supposed to round to the nearest hundredth. So I'll find the hundreds place, 2 past the decimal, look 1 space to the right. That's 4 or lower, so I'll round this down to 15.71, and that would be the length of that side. Poll went great. Let me know if you have any questions. All right. Here's a question that you might not see as a similar triangle question right away, but as we start drawing it out, that's where the similar triangles become more obvious. A 3-foot-tall dog casts a shadow that's 8 feet long. At the same time, a 13-foot tree is casting a shadow. How long is the shadow? Again, doesn't necessarily feel like similar triangles right away, but if we draw this, and this doesn't have to be a work of art, but I've got my 3-foot-tall dog right here, and it's casting a shadow that's 8 feet long, so it's got a shadow down here that's 8 feet long. And what that means is that, you know, the sun is up here in the sky creating that shadow by shining rays down. And hey, look at that. The rays of the sun coming down help me see that there's a triangle involved here. Hey, if there's a similar triangle involved with the tree, then I'll be able to use similar triangles. I'll be able to use a proportion to solve this. And that's exactly what's going on. That's the reason for at the same time. Because in order to have a similar triangle, we need to be the sun at the same location in the sky. We need this angle to be the same as the angle in the other triangle that we're going to create. And because it's at the same time of day, then that's true. A 13-foot tree, so it's 13 feet tall, is casting a shadow. I don't know how long the shadow is. That's what I'm trying to find out. But I do know that at the same time of day, the sun is casting those rays down. Since these angles are the same, we have a 90-degree angle down here. All 3 angles in the triangles are the same, so they are similar triangles. That means I'm going to use a proportion to solve. Let me know if that is uncomfortable at all. And now, in order to solve this, I will set up my proportion. Let's see here. My corresponding parts, I have 3 and 13. So 3 in the little triangle, 13 in the big one, 8 over x. So 8 in the little triangle, x in the big one. You can also think of this logically, if you want to, as height of the dog, height of the tree, shadow of the dog, shadow of the tree. And so there's a logical reason for us setting this up the way we did. You can either look at it as corresponding parts, or you can look at it as corresponding things when we get a real world situation like this. And now we're going to solve. So 8 times 13 is 104, and that's going to equal 3 times x. Just like we did previously, we need to get multiplication to go away, so we'll divide both sides by 3. Those cancel, leaving me with x is whatever 104 divided by 3 is, 34.6666. That keeps going. We were supposed to round to the nearest hundredth, so in this one, we'll find the hundreds place, 2 past the decimal. Look 1 space to the right, that's 5 or bigger. So we'll round this up to 34.67. How long is the shadow? 34.67. It would be feet, but you just report the number. Let me know if you have any questions on what we did there before I have you try one that's similar. Okay, here goes. A 12-foot tall tree casts a shadow that's 16 feet long. At the same time, a water tower casts a 20-foot long shadow. How tall is the water tower, rounded to the nearest hundredth? I'll set up a poll for this and let you try it. We'll go another 20 seconds and then talk through it together. All right, let's see how we did here. Unanimous again, perfect. Today's going exactly as I hoped. Similarity is usually a group of content that goes really well and we don't have too much trouble. And that's where we're pointing, which is excellent. Okay, so let's see. 12-foot tall tree casts a shadow that's 16 feet long. So I have a 12-foot tall tree in a shadow that's 16 feet long. The sun's rays make my triangle for me. At the same time, a water tower casts a 20-foot long shadow, but I want to know how tall it is. So now it's that saying that I don't know. And again, the sun's rays give me my similar triangles. The relationship that I do know between these two is 16 corresponds with 20. Those would be the length of the shadows. And then 12 corresponds to X. And what we've got here is shadow of the tree, shadow of the tower, height of the tree, height of the tower, and it's height of the tower that we're trying to find. So we'll go ahead and cross multiply and solve this thing. 20 times 12 is 240. 16 times X. We'll divide both sides by 16. And it lands on 15 exactly. So we don't really need to round this to the nearest hundredth. We just come up with 15.00 or just 15. Either one of those is fine for the height of the tower. Let me know if you have any questions, but again, feels like we're doing great. Here's one that doesn't involve triangles. So far, we've been working with triangles, triangles, triangles. Here's one where we have this sort of stretched out pentagon. It's not a regular hexagon, it's stretched out, or excuse me, pentagon. It's not a regular pentagon, it's kind of stretched out a little bit and tall and narrow. And we are told that those are similar figures. What I want you to do is find the length of side BC to the nearest 10th. I'll go ahead and set up a poll for you. The shape that we're working with has changed, but the philosophy has not. We're still looking for a relationship between the two figures. And then we use that relationship along with corresponding parts to set up our proportion that we're going to use to find the side length that we don't know, the one that we're looking for. We go another 15 or 20 seconds. Let's go 20 seconds, and then we'll talk about this one. If you need more time, it's okay to let me know. If you get an answer that's not one of the ones shown, pick the one that's closest to yours. You know the drill. Today's gone extremely well. I think we've been unanimous right down the line, which is pretty terrific. All right, let's see how we did on this one. Unanimous again. All right, let's talk through it. If you have any questions as we go through it, make sure you let me know. So in this one, we don't have triangles, but the idea is the same, that we are looking for a relationship between the two figures, and then we're going to use that to find the thing we're looking for. That relationship, I only know one side length here, and it's AE, has a length of 5. The corresponding part over here has a length of 8. So I can set up a relationship between those as 8 over 5. You can do 5 over 8 if you wanted to. Just make sure you're consistent when you set up your other proportion. The one we're looking for is BC. That's down here, so that's going to correspond to this side that has a length of 11. BC is the thing I don't know. I can call that X. Since I did 8 over 5, I'm going to do 11 over X. Now we've got our proportion, so we can solve. We'll have 11 times 5, 8 times X. We'll divide both sides by 8, and then 55 divided by 8 is 6.875 is equal to X. Here I was told to round to the nearest tenth. So we'll find the tenths place. Look one space to the right. That's 5 or larger. So we'll round up to 6.9. So how long was this side right here? It has a length of 6.9. We weren't given units. We don't know if it's inches, feet, yards. Doesn't matter. It has a length of 6.9. Let me know if you have any questions on that one. All right. Before I set up the poll for this one, here we do have similar triangles. I want to talk to you a little bit about how we have similar triangles. Or we could be told we have similar triangles. Here we can see we have a right angle, and then and what we've got, we haven't talked like alternate interior angles, but that's what's going on here. You'd be told that you had similar triangles. What I want you to be careful with here, though, is identifying your corresponding parts, because what you'll notice is a lot of times, you know, we've got triangle DCE here. Very often our triangles like this, and we're like, yeah, the corresponding parts are extremely obvious. In a picture like this one, they're not necessarily obvious. Now, we have a horizontal line, we have a vertical line, we have right triangles, so we have a hypotenuse. So the corresponding parts aren't that hard to find. You just have to kind of think, what might I do to this triangle over here if I was going to have it line up correctly with the other one? And, you know, well, if we did a reflection across AC, we'd have a triangle here. That still doesn't make it easy, but then we could do a reflection across DC, and now I have a triangle here, and okay, that's how I could see the corresponding parts easy. You may not need to go to all that trouble. Make sure you identify the corresponding parts correctly when you do this one. And what I'm going to tell you is that AB has a length of 22, AC has a length of 12, DE has a length of 38, and I want you to find the length of CE. I'm going to set up a poll for this one. This is most challenging of the ones we've seen, but given how well today's gone, I'm thinking finding CE is going to be something that you'll be able to do. Definitely try this one because it's a little more challenging than the ones we've seen so far. We can go another 30 seconds and then talk through this one. And if you need more time, it's okay to let me know. This one is a little bit more challenging than the others. All right, let's see how we did here. Okay, first one that's not unanimous today. It could be as innocent as just picking the wrong button, but we'll see how it goes when we talk through it. If you have questions as we go through this, make sure you let me know. So what we were told is that AB has a length of 22. Sorry, AB has a length of 22. AC has a length of 12. DE has a length of 38, and you're asked for the length of CE. Now, in some ways, I kind of gave you a huge hint about what the corresponding parts are by what you've been given here and what you haven't. We also talked about it, but you know, our hypotenuse is 22. In the other triangle, our hypotenuse is 38. So we're going to have a relationship between those. I could say big triangle over little triangle is 38 over 22. You could set it up the other way as long as you're consistent when you do the other thing. And then identifying the idea that, well, there's a right triangle, there's a right triangle. This is the horizontal line coming off the right triangle, and so is this. Those are corresponding parts here. So the relationship I have is 12 goes with X. And if I have a big triangle on top, little triangle on bottom, then I need big triangle on top, little triangle on the bottom. Now I've got my proportion that I can solve. 22x is equal to whatever 38 times 12 is, 456. We'll divide both sides by 22. 20.727272. And here we were told to round to the nearest hundredth. So we'll find the hundreds place, look one space to the right, 5 or bigger. So we'll round this to 20.73 as that side length down there. If you see one like this, just sort of take a minute, step back, and make sure you're identifying corresponding parts correctly before you dive into your proportion. Let me know if you have any questions on that. Okay, very good. I only have one more thing to say about section 10.3 in similarity, and that's just sort of a note, a helpful hint with the homework. When you're working on number 8C, what it's asking for is side DE. Just to make sure that's clear, I'm not positive that the question itself makes it that obvious. So just a little note, number 8C is